Hi, this is Noah Dennis and Keith Graeff, and this is our final project for 530.241 Electronics and Instrumentation at Johns Hopkins University. The first part of our circuit can be seen on the bottom right of your screen and is the charging circuit. Here we use a comparator to compare two voltages. One is a voltage reference from 4.7 volt Zener diode in reverse breakdown, and the other is the voltage of the capacitor. Here, the way we have it set up, the capacitor will stop charging when the voltage of the capacitor exceeds 4.7 volts. The 4.7 volt Zener diode gives a relatively constant voltage reference of 4.7 volts because Zener diodes in reverse breakdown give relatively constant voltages for varying amounts of current. We also use an NPN transistor here to make sure that the capacitor charges faster. The second part of our circuit is an illumination circuit. Here we use a comparator to compare the voltage from 2.5 volt Zener diode in forward bias to the voltage of the solar panel. The voltage of the Zener diode in forward bias is about 0.7 volts, which gives us a constant reference of about 0.7 volts. This way, when the voltage of the solar panel is exceeding 0.7 volts, the white LED, which is painted red here, will be turned off, and when it's below 0.7 volts, it will be turned on.
Thank you.
The third part of our circuit is the charge monitoring circuit, which can be seen on the left side of your screen. Here, we have a red LED and a green LED. The red LED will be turned on for the first 50% of the usable voltage of the white LED, and the green LED will be on for the remaining 50%. Also, when either LED is turned on, the light has to flash 100 milliseconds of every 2 seconds. To do this, we use a TS555 timer. In order for the red LED to be turned on when the other was turned off and vice versa, we use two comparators. For the last part of our circuit, we have the flashing beacon circuit, which can be seen towards the top right of your screen. Here, we attach this circuit to the illumination circuit so that the flashing beacon light, which is a red LED, will be on when the voltage of the solar panel is below 0.7 volts and off if it's above 0.7 volts. Also for the flashing beacon circuit, we used a TS555 timer so that the LED would flash for 100 milliseconds every second when it's turned on. Also, we used an NPN transistor to amplify the current so that when the LED is on, it will be flashing brightly. Now that we have explained our circuit to you, we will show how it actually works. Right now, our circuit is charging. We will wait for it to charge to a higher voltage to show how everything works. Now that we have charged our circuit to about 4.5 volts, which is pretty close to fully charged, we can show how everything works. Right now, because the voltage of the capacitor is about 4.5 volts, we are above 50% of the white LED's usable voltage. This is why the green LED is turned on and is flashing 100 milliseconds of every 2 seconds. Now I will demonstrate night and day. Right now, since the solar panel is out of the sun, the voltage from the solar panel is below 0.7 volts. This is why the white LED is turned on, and so is the flashing beacon. Also, the flashing beacon is blinking at 100 milliseconds of every second. Right here we have a dimming switch so that it can change the intensity of the white LED.
Are you talking about here?
Right here we have a master on-off switch which turns on and off the circuit. Now it's off, now it's on, now it's off, now it's on. Also, when I put this back into the sun, the flashing beacon LED and the white LED turn off because the voltage from the solar panel is exceeding 0.7 volts. Night, day, night, day, night. Also, this is the switch for the flashing beacon. Now the flashing beacon is off. Now it's on again.
Well, these blocks really should be taken out because they're dangerous.
The green LED is still flashing because it is above 50% of the usable voltage. But in a few moments, we will reach the 50% point, and the red LED will start flashing and the green LED will turn off.
In a new assortment where we have one value per drawer, because these things get all messed up. Yep. And also, it'd be easier.
As you can see, the red LED is now turned on and blinking at 100 milliseconds of every 2 seconds. This shows that we have reached below 50% of the white LED's usable voltage. Also, you can see that the white LED is still very bright. This shows that our that relatively constant current is going through the LED. Now we have shown that our circuit actually works to you guys. And ta-da! This is it.
Or we can go, this is nighttime.
Right now that our circuit is charged 4.54 volts, we can implement how it actually works.
Oh, hi there, Elise. How are you? This is how it is now. You just walk by me and don't say hi. Yeah, I get it. I get it. Why do you have bruises on your knees?
Right now, I'm about to take the solar panel out of the sun so that the voltage coming out of the solar panel is less than 0.7 volts. Here, you can see that the white LED is turned on, signifying that it is nighttime. Also, because the voltage from the capacitor is greater than 4.1 volts, the green LED is on and is flashing at 100 milliseconds every 2 seconds.
Something's wrong.
Yep. Fuck.
Our beacon isn't flashing.
Is it on?
No, our beacon's off. You can blame me on that one. The dip switch is off. Put the top dip switch the other way.
Oh, okay. God damn it, that's recording too.